Hello, we're in section 2.6 and we just saw how to use a super handy theorem for finding limits at positive or negative infinity. So we're going to continue along with this idea here. We're still using trick number 1, multiplying things by the reciprocal of the highest power of x in the denominator. Saw how to apply that to rational functions, but there's a little exception that we're going to look at now, or not an exception so much as a special case, really. And the note here is to watch out for roots. Okay, we need to make our multiplier compatible with these roots. Now, we're going to jump right into this example 3 here. Notice that in this case, we wouldn't necessarily want to use a conjugate because we just have a radical expression on top. And anyway, when we're letting x go to infinity, that's where we really want to use this multiply by the reciprocal trick rather than going straight for a conjugate type of thing. So yeah, when you see that infinity there, really try to use the multiplier trick. All right, so we need to multiply by the highest power of x in the denominator, which we can see is going to be x to the first. Okay, so there's our highest power. So highest power is x, and so the reciprocal of that is 1 over x, and so that would be our multiplier. 1 over x, multiply the numerator and denominator. Okay, but when we do this, we run into a little bit of an issue with our distribution. In the denominator, it works fine. Okay, we distribute, and in our denominator, we would have 1 minus 2 over x. But in the numerator, we have, well, our multiplier is not a root, and then everything else in the numerator is under a square root. So they don't really go together. We have 1 over x times the square root of 4x squared plus 1. And yeah, that kind of runs into an issue for us because we can't really multiply these things together as is. Where we can multiply this, and this is the new idea here, is if we write this 1 over x term underneath the square root itself, and then we'll be able to combine those two square roots together, all right, using a property of radicals, and it'll work out a lot nicer. So we're going to write this as a square root. Okay, so to write this as a square root, well, we've got 1 over x, and we kind of want to think about, okay, what could that be the square root of? And we could say that, well, 1 is the square root of 1. Okay, that takes care of the numerator. And then we got to think, okay, what is the x the square root of? Well, using just kind of another property of radicals here, we could say that x is the square root of x squared. And don't worry about the plus or minus too much on this. The goal is just to get 1 over x underneath a square root. Okay, so 1 is the square root of 1. X is the square root of x squared. And then if the numerator and denominator here are both square roots, we have a property of radicals that says we can combine those together into a single square root. Okay, so 1 over x is the same thing as the square root of 1 over x squared. All right, so we're going to put that into our limit expression right here for the 1 over x. Okay, let's do it. Keep writing limit. We haven't put any numbers in yet. So square root of 1 over x squared. That's our new way of writing that. We're making a compatible multiplier there. Still got our square root of 4x squared plus 1. Still got 1 minus 2 over x in the denominator. But yeah, this is advantageous here because now that both of the terms in the numerator are underneath square roots, now we can combine them. So now we can combine and multiply. Okay, because remember the property we're using here is square root of a times square root of b if you've got two square roots multiplied together. It's the same thing as merging those into a single square root and doing the multiplication underneath. And that works for all types of roots, not just square roots. So that could be a cube root, a fourth root, etc. Okay, so what this is going to look like now is the limit as x approaches infinity of, I'm going to write the radicand here, stuff under the square root first. 1 over x squared and then 4x squared plus 1 are going to be underneath a single radical. And then we have 1 minus 2 over x in the denominator. Okay, so that makes our distribution possible here. Now we can distribute underneath the radical. Okay, and so underneath the radical, we're going to have a 4 for the first term, and then 1 over x squared for the second. It's still underneath the square root. Okay, but now you can start to see those familiar terms coming back up that we saw in our previous examples. Okay, those constant over some power of x. Those are the things I've been highlighting in purple here. These are the terms that are going to approach 0 as x gets very, very large because of our useful theorem and its extension. Okay, anything that looks like a constant over x to some rational power is going to approach 0. So in our example here, we can see the 1 over x squared is going to approach 0, and the 2 over x is going to approach 0. And that's exactly what we're going to let them do now. So this is the part where we're going to put in values, so we get to stop writing limit. And so you'd have the square root of 4 plus 0 over 1 minus 0. Okay. And so square root of 4 over 1, that'd be 2 over 1, and so that's 2. And so that is our limit for this.